Section 5.4 is going to be the last section we are going to cover in chapter 5. And this is about the sum and difference identities. So the sum and difference identities are listed here in this chart. It says that the sum of angle alpha plus angle beta is equal to the sum cosine. I'm going to refer to the first and the second, okay? Alpha as being the first angle and beta being the second angle. So cosine of the first plus the second is cosine of the first, cosine of the second, minus sine of the first, sine of the second. Sine of the first plus the second is equal to sine of the first, cosine of the second, plus cosine of the first, sine of the second. And tangent of the first plus the second is equal to tangent of the first plus tangent of the second over 1 minus tangent of the first, tangent of the second. For difference identities, cosine of the first minus the second is cosine of the first, cosine of the second plus sine of the first, sine of the second. Sine of the first minus the second is sine of the first, cosine of the second, minus cosine the first, sine the second. And tangent of the difference, the first minus the second is tangent of the first minus tangent of the second over 1 plus tangent of the first, tangent of the second. I haven't seen any teacher require you to memorize this. So you will be given a formula sheet when you need to perform problems that require these identities. So I'm going to go ahead and show you how to apply these. There are two guided problems. The first one says find cosine of 15 degrees. You should use the special angles 0, 30, 45, 60, 90. So what you need to do first is rewrite cosine 15 degrees as either a sum or a difference of two of our special angles. So what I did is I rewrote this as cosine of 60 minus 45. 60 minus 45 gives me 15. So now that I have it written as the difference of two of the special angles, I can apply the identity that is the difference cosine of the difference of two angles. So difference of two angles. So as you can see here, the difference of two angles, cosine of a difference is over here. So it says cosine of the difference is going to be cosine of the first, cosine of the second, plus sine of the first, sine of the second. So I just need to apply that. So now that I have my difference, so that would be equal to cosine of the first, cosine of the second. So it's cosine 60, cosine 45, plus sine of the first, sine of the second. So now I should know those values. Hopefully you memorize them. Cosine 60 is 1/2. So this is equal to 1/2 times cosine 45 is radical 2 over 2 plus sine 60 is radical 3 over 2 and times sine 45, which is radical 2 over 2. And now I just need to evaluate that. Order of operation says I have to multiply first. So that means 1/2 times radical 2 over 2 is equal to square root of 2 over 4. And square root of 3 times square root of 2 is square root of 6. Multiply the insides. 2 times 2 is 4. I have the same denominator, so I can just write this as square root of 2 plus square root of 6 over 4. Done. That's the exact answer. Okay? Now, let's take a look at the second example. The second example is in radians. It's asking you to find sine of 5 pi over 12. I am going to erase this so I have more room. And I'll do the second part. Okay. All right, I have enough room here. Let's just erase the bottom as well. Okay. So this says 1b, sine 5 pi over 12. So once again, I have to write it either as a sum or a difference of two of my special angles. I wrote it as sine 3 pi over 12, which is pi over 4. Actually, let me do it the long way. 3 pi over 12 plus 2 pi over 12, which is going to be pi over 6. But I wanted to write this this way so you would see where it comes from, which is the same as pi sine pi over 4 plus pi over 6. Pi over 6 is 30, pi over 4 is 45. So now I have to use the identity for some sine of sum of two angles. So now I go on and I can write it as sine of the first cosine of the second. So this is my alpha, that's my beta. I'm getting that from up here. Okay, so sine of a sum. So sine of the first cosine of the second plus cosine of the first sine of the second. That's what I'm doing. Okay, so sine of the first cosine of the second plus cosine of the first sine of the second. So now I know that sine pi over 4 is square root of 2 over 2. And cosine pi over 6 is radical 3 over 2 plus cosine pi over 4 is square root of 2 over 2. Sine pi over 6 is 1/2. I multiply now. And square root of 2 times square root of 3 square root of 6. 2 times 2 is 4 plus square root of 2 over 4. Well, I guess I'm gonna get the same answer as before, perhaps. Yeah. So it's equal to square root of 6 plus square root of 2 over 4. That is my answer in exact form. Next problem. Find the exact value of cosine 7 pi over 8 cosine 5 pi over 24 plus sine 7 pi over 8 sine 5 pi over 24. So now I have to match this to one of my identities. I want sine of the first, cosine of the first, cosine of the second, plus sine of the first, sine of the second. So if I look up there, it's going to be the cosine rule for a difference. Cosine rule for a difference. I get, if you look over here, cosine of the first, cosine of the second, which is what I had, plus sine of the first, sine of the second. So I need to write it in this form. I'm going backwards. So I would write that as cosine of the first minus the second. Now, I can actually find a common denominator and evaluate. So this would give me cosine of 3 times 21. 21 pi over 28 minus 24 minus 5 pi over 24. And what this equals is cosine 16 pi over 24 which can be reduced to cosine 2 pi over 3. And you should know that cosine of 2 pi over 3, if you go back, unit circle, that would be 3 pi over 3 minus pi over 3. So the reference angle is pi over 3, which is 60. Cosine 60 is 1/2, but this is the second quadrant, so it should be negative 1/2. Okay. All right. We are going on to 3b. So it says simplify tangent 6x minus tangent 7x over 1 plus tangent 6x tangent 7x. So what I'm going to do is I'll refer back to the top and see what identity we're talking about. And in this case, I have a minus in between. So it appears to be this. So my problem looks like this, is in this form. So I have to change to tangent of the first minus the second. So now I can rewrite this whole thing as tangent of the difference, so 6x minus 7x. And now I can combine 6x minus 7x. I get tangent negative x, which, if you remember, that's an odd function, so negative tangent x. Okay. Then in the textbook, you had an example for A and for B for this. I am not really going to ask you to do any problems like for A, but I wanted to show you how to do it anyhow. You might be interested. So, but it will not be in your exercise, sorry, or tests or anything like that. So the way to do this one, essentially, this is your first. This is your second. So you're talking about cosine of a sum. So if you're talking cosine of a sum, here you are, cosine of a sum, this one. So I'm going to rewrite that as cosine arcsine 2x times cosine of the second, which is arc cosine x, minus, and now I'm gonna do it sine of the first, sine of the second. So sine of the first, which should be arc sine 2x times sine of the second, which is arc cosine x. Now, the thing is, I don't know the value for arc sine 2x and arc sine x. So I need to draw a triangle and figure it out algebraically. Okay. So let's say I pick an acute angle. Let's say this is 90. And I say, so if I know that this is my angle here, my alpha, if I know sine of that angle would be opposite of a hypotenuse, which means the side opposite of that angle would be 2x, the hypotenuse would be 1. And by applying Pythagorean theorem, I would find that this leg should be equal to the hypotenuse squared, which is 1, minus the quantity 2x squared, which should be 4x squared. And then I have to do it the same for the arc cosine of x. So let's say, for instance, let's say this is my acute angle over here. If this is x, then this has to be 1, because I know that cosine of this angle would be adjacent over hypotenuse, which would make this guy here the hypotenuse squared minus the other leg squared. So 1 minus x squared. So now I have the value, I can find actually any sine, cosine for those. So now I have to do, so sine of arc sine of 2x would be equal to, cosine of this angle here would be this, right? So cosine of that would be square root of 1 minus 4x squared times, I have to go back here. So cosine of that is this. Cosine of r cosine 2x is that, times cosine of r cosine x would be just x. Because if you look over here, cosine of this angle on this side, cosine of this would be adjacent over hypotenuse, so just x. So I can do times x minus, now I have to work on the second part, which is right here, sine of arc sine 2x. So sine of arc sine 2x would actually be 2x, because now we're talking this one, opposite over hypotenuse. So 2x times, now the other part, which is sine of arc cosine x. So sine of arc cosine x would be, for the other triangle, so that would be 1 minus square root of x for this angle over here, opposite. So 1 minus square root of x squared, square root of 1 minus x squared. And from there, there's nothing else I can do. I mean, I could distribute, but I'm not going to be able to simplify any further. So that should be my answer. Okay. Moving on to 5b, which you will be asked to perform. 5a, sorry. This is asking you to verify each co-function identity using a difference identity. So what they want you to do is do this to show that that equals sine x. So it's the cosine of a difference. So cosine of a difference would be cosine of the first, cosine of the second, plus sine of the first, sine of the second. So cosine pi over 2 is 0. So I get 0 times cosine x, or I can just do this, plus sine pi over 2 would be 1. So 1 times sine x, which is just sine x. So this goes away, and I just verified that equals sine x. Okay. For 5b, I have to verify a confunction, once again, using sum or difference. So cosecant pi over 2 minus theta is equal to secant theta. I am going to go ahead and I am going to apply, because cosecant is the reciprocal of sine, I am going to apply the identity for sine, and then I can do the reciprocal for cosine and get the secant. So I am going to apply, I'm going to say that sine pi over 2 minus theta is the same as, it's a difference, sine of a difference. So sine pi over 2 cosine of the second minus cosine of the first sine of the second. So sine pi over 2 is 1. 1 times cosine theta is cosine theta, minus cosine pi over 2 is 0. So 0 times sine theta, 0 times anything is 0. I'm left with cosine theta. So the reciprocal of, since cosecant theta is 1 over sine theta, secant theta is 1 over cosine theta. Then I can go ahead and show that I verified that identity. And then the final problem asks you to find all the solutions to that equation in that interval. And as you can see here, there is a sum of two angles and a difference of two angles. So I have to apply my identities, the sum and difference identities. So cosine of a sum is going to be cosine of the first times cosine of the second minus sine of the first, sine of the second. This is just for this part here, okay? Let's not get confused. This, I'll do it in, yeah, let me try something else. Yeah, then let's color code this. So let's do this one in blue. So this thing becomes this whole blue thing here. Cosine of the first, cosine of the second, minus sine of the first, sine of the second. And now I am going to do minus. And now I'm going to do the red, which is going to be, let me put parentheses here to make sure. So it's going to be sine of the first, cosine of the second, minus cosine of the first, sine of the second, equals 0. All right, so now I can start evaluating. Cosine pi is cosine pi is -1. So -1, this is -1 times cosine pi. So I get negative cosine pi, and then sine pi is 0. So sine x times 0. So this goes away. So negative cosine pi, and then I have to do minus, and this should be sine x cosine pi is -1. So -1 times sine x is negative sine x. And then the second part, sine pi is 0. So since this is 0, then this goes away. So I'm left with equals 0. So now I have I have negative cosine, oh, that should be x, because, sorry, this should be x. And this is x. Okay. I think everything else is fine. Yeah, because cosine pi was -1. So, yeah. So this was -1. That's what went there. Okay. So now I have negative cosine x plus sine x equals 0. So I personally added cosine x to both sides, and I got sine x equals cosine x. So what is the angle that has values for sine and cosine the same? And the answer is 45 degrees, or pi over 4. Because if you remember your unit circle, pi over 4, the cosine value and sine value are square root of 2 over 2. And then here they would both be negative, which would work as well. So this would be 5 pi over 4. So my answer should be in that interval, 5 pi over 4 and 5 pi over 4. And now I am done. Okay, thank you.